Okay, this is the third section in chapter 2 here, which is on wind. And so wind is horizontal movement of air from high pressure to low pressure. So when we feel wind, it's moving from high pressure to low pressure. It's just basically air movement that's caused because we bring equal pressure. And so wind just basically takes that air and tries to equal out the pressure by moving it around. So they're caused by difference in air pressure, and they're described by direction and speed. There's a picture here of a wind vane, which tells you a little bit about direction, and then there's also a part of it that as it turns, it tells you the speed. So we use this instrument here to tell us a little bit about the direction and speed of the wind, so we know how it's moving. So where is it coming from? How fast is it going? Those two things would be important to us as we're trying to figure out what's going on with our weather. Okay, a couple different types of wind. Local winds being one type. These are very local. They move over short distances, and they really only affect people on the coastal areas because they're caused by how water can be unevenly heated, because at times the land is heated quicker than the water, which causes like some of that cooler air to move into onto Earth or onto the land a little bit quicker, or opposite can happen as well. When the water's been heated at night and the air around land is cooled down, that hot air or hot wind or hot air will go from the water that's been heated all day, and the cool air from the land will blow in there. So we have what we call a sea breeze and a land breeze. So sea breezes happen as the land heats up quicker than the water, and so the heat rises from the land and it pulls in that cooler air from the water, which hasn't heated as quickly. At the end of the day or in the evening, we have what we call land breeze. So the heat is moving off of the water, and because it's moving off of the water, moving up from the water, it allows that cooler air from land, which has cooled down quicker. So water heats up quicker and it cools down. Water heats up slower and it cools down slower as well, which causes this land and sea breeze, which is why if you live in a coastal area, these will affect you more. Okay, global winds are going to affect us more because they blow steadily from specific directions over long distances, and it is very dependent on the angle of the sun's rays and how much the sun rays are hitting the area, which will determine, how the air pressure, how that goes, and which causes, that air to move from one direction to another based on that difference in air pressure. Okay, Earth's rotation helps the winds to curve, because obviously they want to blow straight, but because Earth is rotating and it's circular, it causes the winds to curve, and we call this the Coriolis effect. So the actual wind path is different than the wind would be if the Earth did not rotate. Because the Earth is rotating, the Coriolis effect basically causes those winds to not go straight. It causes them to kind of curve, and that's because the Earth is curved, the Earth is round, and so it causes that curved ability of those winds as they go around the Earth. Okay, so different global wind belts. I'm going to put this on every slide, this picture here, and it shows you all the different types of global winds. We'll start with the doldrums. Doldrums are near the Earth equator. Because the sun heats that surface so directly and so strongly, there isn't a lot of wind in the equator type area. Because that even heating over the entire surface near the equator, we call those the doldrums. Force latitudes. These are found 30 degrees north and 30 degrees south. And so those are right, right above the doldrums and right below the doldrums. Are a little bit above, a little bit below the doldrums. And again, another place where air stops moving. And when air stops moving, then we don't have a lot of wind in those areas. So there's belts of calm air there. The reason why they're called forced latitudes is because back when sailing was the main way for people to get around from different landmass to different landmass, if you got stuck in a forced latitudes, you didn't move. You need wind for sailing to work. They didn't have motors in their boat, so they needed wind to help move them along. If they got stuck in the forced latitudes, a lot of times they want to lighten up the boat, so they'd start throwing things overboard. Horses being one of the things that they would throw overboard in that situation to try and help themselves move faster. That's why they're called forced latitudes. So 30 degrees north, 30 degrees south, just a kind of a little small belt in those areas where there's just not a lot of wind. Okay, so the trade winds are going to be found near the equator. They're 30 degrees north and 30 degrees south. So from the equator to the forced latitudes, you find the trade winds. And trade winds are good they blow very, very nicely. They form a very steady easterly wind. So if you were a sailor, this is where you'd want to go. You'd want to go, you'd travel east this way, so you'd get into the trade winds area, and it would blow you very nice and steady in an easterly direction. Prevailing westerlies, these are above the horse latitudes to 60 degrees north or 60 degrees south, or below the horse latitudes. These blow from west to east in this situation, so they're blowing west to east, and they play a very important role in our weather here in the United States because a lot of that section is found over a large part of the United States. Okay, last thing is the polar easterlies. These are going to be found like near the poles, basically. So this is cold air that sinks, and it mixes with the prevailing westerly, and again has a large effect on our weather, especially during the winter time, allowing kind of colder winds to blow in from the north in these situations because they mix in with those prevailing westerlies, because those kind of butt up to each other, those two global wind paths. Jet streams are found 10 kilometers above Earth's surface, and these are bands of high-speed winds. A lot of times if jets are flying in this area, it helps to kind of cut down the amount of gas that they need to use or fuel they need to use because basically the wind is helping to blow. This is the end of the section on wind. We'll get into a little bit more on weather. We're kind of starting to work our way into this. First, we talked about how the Earth is heated, and wind becomes a part of this as well because it affects our weather as well. So this is in your packet or online as far as the homework goes on PowerSchool Learning, and enjoy.